Let me just do this. Okay. So this is simply application of cosine rule. So if you have to apply the cosine rule, so what you need to do is you can take any of them. Yeah? So the sides have been given, so you can use in the form your cos theta, or you can do your r squared, 6 squared is equal to 5p squared plus 4p squared. So this square, because since we know this angle, so 6 square is equal to 5p, 4p squared minus 2 into 5p into 4p into cos of the angle between them, cos of 0.7. That's it, work it out. 6 square is 36, 25p squared plus 16p squared minus 5 2s are 10, 40p squared cos 0.7. So 36 is equal to 41p squared minus 40p squared cos 0.7. So 36 is equal to, if you remove p square common, you will be left with 41 minus 40 cos 0.7. So that's your part A, part 1. Then find the value of p. So you put this in the calculator. The value of p. Now the value of p would be plus or minus. What is that answer you got?
So plus minus
so if you put it,
1.8599.
so 1.86. Correct. So 3 significant figures were not specified. So your p can be negative because p, otherwise your side would be negative. So you give your answer as 1.86. Because since it's a quadratic equation, you have to show 2 solutions. So in the next part it continues. So with this as the center, the circle has been drawn, this arc has been drawn. The circle cuts CA at point D and ADB. ADB is an obtuse angle. Part of the circle is shown in the figure, right on the length of BD. So you know that obviously this is the radius. So this is 6, this is also 6. Correct? So BD is equal to 6, the radius of the circle. BD is equal to 6, radius of the circle. Hint, in such long questions, they're asking you to find ADB.
Yes.
So you need to look at the other parts also. You've got these parts. So it's the same question which is continued.
Oh,
so
the same big
triangle. Yeah, it's the same big triangle. So that's a hint. Now, what do you have in this case is, so you have to use the earlier part, that was the hint that I gave you. So that you succeeded in doing that very well. So your AB, so length of AB will be 4 times the value of P that we got. Now you can't use 1.86, so make it a point that you use the entire value which is there. So 1.859956, at least use more significant figures, correct? So 7.43, 98, 24, correct? So that's the value of this 7.44. I'm just writing in brief over here. Now you need to find out this value. So if you look at triangle ADB, I can use the sine rule, because whenever you know an opposite angle and side, you should use the sine rule. So I use sine D upon 7.43984 is equal to sine 0.7 divided by 6. Now you've been given that ADB is an obtuse angle. Now this is important. So if you use sine inverse, or if you solve it, you should realize that your answer should be more than 1.57 radians and less than 3.14. Remember, 1.57 is 90 degrees. And your pi radian, pi is 3.14 approximately, and this is your 180 degrees. So your answer, choose the answer between 1.57 and 3.14 if you use solve n.
Yes, sir.
So that means your angle D will work out to be 2.21627. So basically 3 significant figures, your answer will be 2.22. That's a D. Acha, if you end up using sine inverse, you'll get 0.9 something.
Yeah.
But remember that your calculator gives you only the acute angle. So then you have to remember that you have to use all silver teacups, and your sign is positive here and here, and you do pi minus that 0.9 whatever. So that will still give you 2.22. So it's always better to use solvent when you're doing sine inverse. This is your ambiguous case of the sine wave. Okay, continue please. See, what you do in this is the following. So this is 2.22. Now you do so to get this angle, you do pi minus that angle. So if you do pi minus that, you get 0.925553 something you get. 9253. Sorry, I forgot to put the 2. One second.
Exactly that.
9253. Now base angles are equal, so this will also be 0.9253. Then you do sum of angles of triangle. So then you do pi minus 2 times 0.9253. You can take more significant figures. On calculator I've taken more significant figures, and I'll end up getting my angle DBC. Remember, 180 is your pi radians, and I'll end up getting this angle as 1.29 radians to 2 decimal places. That's it. So see, what will you do is, so you got D1. So this is your D1. You just use the property, angle properties, and you get that. Now for D part 2, what you have to do is find the area of the shaded part. So I'm erasing this part which are not required. Correct? Erase the parts which are not required. So I'm erasing this part off. And I don't need these parts. So that otherwise it's, So now I'm just focusing on this sector. Now when you're focusing on this sector, this is 2.22. Yeah? No, sorry, 1.29. We got 2.2 is the other one. So we know this is 1.29. Okay. So now you will find the area of this entire sector. The area of the entire sector is what? Area of the sector is equal to half theta r square. So half into 1.29 into the radius is 6, because that's your 6 square. So you'll find, so if I have entered into my calculator, I'll just write the answer over here. You type it in your calculator, you get 23.237046. Yeah, whatever, that because of the rounding error. Because you have 3-4 significant figures should be correct. Then you find the area of the triangle which is there. Triangle, that's your triangle DBC. So you're finding, so you're taking this entire sector, correct? And you're taking this triangle and you're subtracting it, and you'll get the area of this part basically. So area of triangle DBC is equal to half AB sin C. So half into 6 into 6 into sine of the included angle. So sine of 1.29. So if you do that, 17.29503, correct? Therefore the required area of the shaded region, you subtract it, and you will get your answer as 5.94.